This video is a very brief discussion of polymers. Now, polymers are large, long-chain molecules with repeating subunits of small molecules that are linked together. The repeating subunits that make up polymers are called monomers. These monomers are linked covalently to other monomers of the same or similar types to make a long chain. Polymers are everywhere. There are naturally occurring polymers like DNA, protein, fats, and oils, and there are man-made, synthetic, or artificial polymers like plastics and polyesters. Addition polymers are polymers with alkene monomers, so the monomers have a double bond in them. And these monomers that have double bonds in them are joined together through multiple addition reaction. So the double bonds become single bonds when the monomers are linked together. So if we have a monomer of ethene, the electrons from each double bond are going to be used to link that monomer to the adjacent monomer. So you can see in polyethylene, we've taken each subunit and used the electrons from the double bonds to link the three monomers together. Now I've left one bond on either side because the polymer could potentially continue to grow on each end. If we take a monomer like vinyl chloride, where one of the carbons has a chlorine substituent, we're going to link them in much the same way, where we're taking our double bonds in our monomer and using them to link each monomer together. We could potentially add more monomers on this side or this side, but in general we've carried out multiple addition reactions to add the vinyl chloride monomers together to make polyvinyl chloride. And you can see each individual monomer linked in a large, long molecule. Now the monomers can have various substituents, so you see a bit of an ester-like substituent here on our alkene monomers, and we can undergo addition reactions to link those together. So we can recognize this as an addition polymer because we've gone from double bonds in our monomers to single bonds in our polymer. So our alkene monomers are reactive because of the double bond, but since we only have single bonds in our addition polymers, they're no longer reactive, and this makes them good containers for chemicals, for solvents, and even for food because they don't react with what's in them. The property of each individual polymer depends on the number of monomers that have been linked together. It depends on the functional groups present on each monomer, and it also depends on something called cross-linking, which we'll see in the next slide. So depending on the functional groups attached to the monomers, individual chains can link together. This makes the polymer structure stronger, because the chains can form networks with one another. Now there are a variety of functional groups on a monomer that would allow for cross-linking, but we'll just look at one example. So these are two separate polymer chains, but their functional group allow us to form sulfur cross-links, and now these two chains, so the one here and the one here, are linked together. Now the whole structure is stronger. Looking at an addition polymer, we can work backwards to see what the alkene monomers must be. So we can see the repeating subunits. Every two carbons has an OH group. So if we separate these subunits from one another by breaking the bonds in between and putting double bonds in the subunits themselves, we can see what the monomers must look like. So we've taken the subunit that repeats and we've gone from single bonds in our polymer to double bonds in our monomer.